Here's the solution to number 8 again. So first thing is I've changed the permutation into its factorial form. That's something that you should know how to do. So it's n factorial over n minus 5 factorial. Same thing with the right hand side. It'll be 120 times n factorial over n minus 3 factorial times 3 factorial. You got to know how to change a combination into its factorial form. So now I notice that n factorial is on both sides of this problem, so I'm going to multiply this side by n factorial and this side by n factorial. What that'll allow me to do, sorry, it should have been divide both sides by n factorial. My mistake, because I want to divide both sides of n factorial. It'll allow me to divide those away. So I'm left with 1 over n minus 5 factorial equals 120 over n minus 3 factorial. Now 3 factorial I can evaluate. That equals 6. Oops, no factorial on that. Okay. I'll erase that. There we go. So now the 6, I can actually divide 6 into 120. 6 goes into 120 20 times, so I can simplify just a little further. I get 1 over n minus 5 factorial equals 20 over n minus 3. Okay, so I've simplified by first expanding my combinations and permutations into factorial form, which allowed me to divide out the n factorial from both sides. And then I did a little bit more simplifying with the 6 and the 120. Now I got to expand these factorials. I'm going to expand the n minus 3 down until it matches the n minus 5. So I'm not going to touch this, but I'm going to expand the n minus 3 factorial. N minus 3 is the first term. Then the next term will be 1 less than it, which is n minus 4. Then the next one will be n minus 5, which is matching over here, matches that term right here. I'm going to stop the factorial at that point. Stop it. Because now, if I multiply both sides by n minus 5 factorial, I can divide away these terms, and I've removed my factorials from the problem. So I get 1 on the left-hand side and 20 over. I'm going to expand this binomial. I get n squared. Oops, I don't need the brackets. So I end up with n squared minus 7n plus 12. Multiply this expression here in the denominator over to the left-hand side. So I get n squared minus 7n plus 12 equals 20. Subtract 20 from both sides, so I can move this 20 over to the 12. I get n squared minus 7n minus 8 equals 0. Now I can factor this. I can solve this. Two numbers that multiply to negative 8 and add to negative 7 will be n minus 8 and n plus 1. Negative 8 plus 1 is negative 7, and negative 8 times 1 is negative 8. So I end up with n is equal to 8, or n is equal to negative 1. Now n is equal to 8 is a valid solution, because if I substitute it into the original problem, this will equal itself. But n equals negative 1 is extraneous. I cannot have n equals negative 1. So for example, I can't have negative 1 choose 3. It doesn't make sense. So this is an extraneous root. This is not a valid answer for this question. And there it is. There's the solution. N equals 8.